Hello everyone, I am Dr. Fahim Ishtaq. Today we continue our lecture to discuss the mathematics for cryptography. In this lecture, we will discuss the binary operations in Z into N. The three binary operations addition, subtraction and multiplication that we discuss for the set Z can also be defined for the set Z into N. The result may need to be mapped to Z into N using the mod operator as shown in the following figure. Actually, two sets of operators are used here. First set, one of the binary operators plus, minus and multiplication, right? And second is the mod operator. We need to use parentheses to emphasize the order of operation. Here we will see the examples for binary operation in Z into N. In first example, you will see that add 7 to 14 in Z into 15. Okay, here they give the set of 15. We will see here 14 plus 7 mod 15, and we do this operation of binary operators. The result is 21 mod 15 equal to 6. Similarly, if we do the mod, we see the example second where they mention subtract 11 from 7 in Z into 13. You have to subtract 11 from 7 mod 13, which got the negative 4. Mod 13 equal to 9. In previously we will see that we use the formula n equal to quotient into m plus r, which will give the result of if there is any negative number. It is requested to you, these are the example where solution is mentioned. This is the example for the purpose of assignment. You people try to do it. If you find any difficulty, we will discuss or you may have to comment on this video and I will give you the solution of all of the given example. Here are the properties for binary operation in Z into N. We mentioned that the two input to the three binary operations in the modular arithmetic can come from Z or Z into N. The following property allow us to first map the two input to Z into N if they are coming from Z before applying the three binary operator plus minus multiplication. Interested reader can also find this property from the book for more detail. In first property, you will see that a plus b mod n, which is equal to a mod n plus b mod n into mod n. Similarly, you will see the second property a minus b mod n, a into mod n minus b into mod n into mod n. And similarly, The third property, A multiplication B mod n, which is A mod n multiply B mod n into mod n. These are the properties for the binary operations in Z into n. Here mention the examples for the property of mod operators. In originally what happened, we will get the value from a set, apply the operators, and then mod operation, then got the value of C. Okay, if we use the properties, then firstly we get the set A B, then do the mod operation A mod n and B mod n. After that we apply the operators, then again we do the mod operations. Similarly here you can see that first we do A mod n minus B mod n, two functions differently perform, and after that this arithmetic operation can be performed. Uh, Operation can be performed with operators, and at the end we do the mod operation, we got the final and result from the set. Here following show the application of above properties, which show that before this I want to explain you something like if we multiply a very large integer by another very large integer, we have an integer that is too large to be stored in computer. Applying the above property make the first two operands smaller before the multiplication is applied. In other words, the property allows us to work with smaller number. This fact will manifest itself more clearly in discussion of the exponential operation in the next chapters. These are the example where we can find a very large number mod of 11, which is equal to 8 plus 9 mod 11. The result is 6. Similarly, we will see in another examples as well. This question is needed a solution from you. You can do by your own. If you find any difficulty, then comment. I will give you the solution of this question. Thank you so much for today's lecture. We will see you in the next lecture.